solar panel are oriented in one fixed direction. So what its role is that it rotate as the sun's radiation changes from morning to the evening shift. It automatically adjusted its position so that solar radiation directly hit that panel.
Yeah, Tamanna. Okay, but how it is going to sense the orientation?
I'm unable to recall that.
Okay, Tamanna. Tamanna, what are your favorite subjects in here? Okay.
So electrical machines, induction machines particularly, and switchgear and protection.
Okay, Tamanna. Switchgear and protection. So, what is the difference between a fuse and a circuit breaker?
Fuse, sir, is directly connected in series with a circuitry. As any fault occurs or any short circuit occurs, its temperature, its strips temperature will get rise and it will get melt. So it disconnects the system or faulty part, and circuit breaker operates as it takes input from the relay. Relay is the actuating circuit, and then circuit breaker operates or it disconnect the line. Yes.
Tamanna, what is the difference between isolator and a circuit breaker?
Difference between isolator and circuit breaker.
Yes.
So circuit breaker operates on faulty or on load conditions, and switch isolator basically used when system is on no load. Its main purpose is to isolate the system so that maintenance can be further achieved.
Okay. What is meant by ACSR conductor?
ACSR conductor. ACSR. I learnt about it. Give me some time.
Okay, Tamanna, take your time.
ACSR. Aluminium conductor is steel reinforced conductor.
Okay. What is that? How it is going to look like and what is its application?
Aluminium conductor is steel reinforced. Basically, it's a aluminium conductor. For example, we have the aluminium strands which are surrounded on around steel conductor. Steel, basically steel rod. The steel is the main purpose to put this steel is to increase its mechanical strength so that it will not sag on transmission line between two poles.
Okay. What is the purpose of using strands in that conductor?
Purpose of using
Strands, multiple strands that might be using, right? Strands.
the main purpose of using multiple strand conductors. I'm unable to recall right now, sir.
Okay, okay. Why the transformer is rated in kVA and while the motor is in kW and HP?
The motors are rated in horsepower or kilowatt because its output is mechanical and it is in mechanical domain. So real power will be more suitable to rate it. And for transformers, it basically does not involve in any power conversion. It have quality of shifting the levels of voltage and currents. So basically, power factor doesn't involve in its operation. That's why, sir.
Yes, okay. What is the difference between analog and digital circuit?
Analog circuit and digital circuit. I don't have knowledge about this circuit, sir. I'm not able to recall, but analog will have its output in real time continuous signal. Digital have in digits particularly.
Digital have digits.
For example, sir, we can take example of watch. We have smartwatch which shows time in digits 7 to
Okay.
8, and analog is continuous in a dial.
Analog is continuous in dial, and okay, you are giving analog watch and digital watch as an analogy for electronic circuits. Okay.
Circuits I'm unable to recall, sir.
Okay, Taman, no problem. What is synchronous condenser?
Synchronous condenser.
Condenser. Yes.
Synchronous condenser, the main purpose of synchronous condenser is to raise the power factor of transmission line. If the power is going more lagging, then it will enhance its power factor.
What is Ferranti effect?
Yes, sir.
Ferranti, what is, sorry, what is Ferranti effect?
Ferranti effect. Ferranti effect is basically when on receiving end side we have voltage higher than the sending end side under no load or lightly loaded conditions.
Okay, okay. Describe different types of switchyard components that we use in a switchyard, electrical switchyard.
Different switching components that we use. We use relays,
Hmm.
circuit breakers, isolators. Further, I'm unable to recall, sir.
Okay, what is current transformer and why it is used?
Current transformer is used. Current transformer is used whenever we need the current. The current in the lower level of currents whenever it is required. It is used in instrumentations, so that the online power which we have online transmission line, it has higher current so that it will lower down the current value on secondary side.
By leaving the current in my primary side, can I open circuit my secondary in a current transformer?
Sir, your full question is not audible. Can you please repeat?
While leaving the current, while the current is flowing in my primary side of the transformer, can I leave the secondary of my current transformer in open circuit condition?
And primary is connected to supply and secondary is in open circuit condition.
Yes. Yes. In this condition, what is it okay?
Secondary open circuit. So this condition basically is used in um, open circuit test where supply is connected on the low voltage side.
No, no, we were talking about the current transformer.
For current transformer.
Yes.
No, sir, because on the secondary, uh, it is uh, it is having lower current and voltage is very much high, so we can't leave it on open circuit condition.
Okay. What will happen if I leave it in open circuit condition?
The voltage will be high. It may result in arcing situation. Yeah, it will ionize the air surrounding there.
Okay, Tamanna, very good. We'll conclude our interview here, Tamanna. Okay, we'll discuss something. There are points on where you need to improve. Tamanna, one thing I am sure that you are taking very good ample time for giving answers, and your answers are also quite good and accurate.
Yes, sir.
बट इसमें मैं क्या इसमें एडवाइस करता हूँ ना, मोस्टली जितना भी क्वेश्चन आपको आया, ऐसे क्वेश्चन आया तो ठीक है, बट आपका इंटरव्यू में मुझे ऐसे लगा कि इट वाज लाइक मोर क्वेश्चन एंड आंसर सेशन, एक डिस्कशन जैसे नहीं हो पाई। एंड बिकॉज
Yes, sir.
आपका आंसर जो है ना, आप एकदम कट शॉर्ट, वेरी क्लियर एंड एक्यूरेट आंसर दे रहे हैं। जब तक आपका आंसर जो चलता रहेगा तब तक जो है ना, ये दिस कंडीशन इज ओके। बट व्हाट आई वुड सजेस्ट इज थोड़ा डिस्कशन बनाने के लिए कोशिश करिए।
Okay, sir.
इन आपका जो आप टाइम ले रहे हैं, एंड आपका टाइम लेके आप सोच के जो आंसर दे रहे हैं, इट्स क्वाइट गुड। ओके, आपका इंट्रोडक्शन में आपने टीसीएस का जो 3 साल जो काम करके छोड़ा, इसको मतलब यू आर सेइंग यू डोंट वांट टू वर्क इन आईटी फील्ड,
Yes, sir.
एंड यू वांट इन अ टेक्निकल फील्ड,
Yes, sir.
राइट? You are applying for a IOCL interview,
Yes, sir.
right?
Yes,
See,
sir.
IOCL, the HR, the HR people might ask you even in IOCL, you might be placed in a sales or retail outlet. You might be a regional sales officer. You might be a marketing officer, right?
Yes, sir. Yes, sir.
So wherein your TCS experience you are giving now, you don't you want to do in a technical field only.
Yes, sir.
ठीक है, इसको है ना आप आंसर है ना आपका टेक्निकल फील्ड ओके, बट इसके अलावा एक और सोचना इसका कैसे आप उधर लेके जाओगे। वो वन पार्ट इज यू डोंट वांट आईटी जॉब, राइट?
सर आई हैव जॉइंड मतलब कि आईटी इसलिए ज्वाइन किया था, फैमिली फाइनेंशियल कंडीशन सही नहीं थी, तो पहला जॉब जो ऑफर हुआ टीसीएस का, तो बिना
यस,
सोचे उसको ज्वाइन करना ही था।
करेक्ट। दिस शुड बी योर आंसर।
यस सर।
This should be your answer rather than saying you don't want IT job, I want technical. आप अभी जो आपने बोला है ना,
ये
this
पहला लाइन में ही बोल देना है, मतलब क्वेश्चन आए उधर
yes,
से।
yes, you can say it, that is a genuine answer, right?
यस सर, इट इज द
Genuine answer को
एक्चुअल आंसर बेसिकली।
that is the actual answer, yet you can give it, no doubt.
यस सर।
बाकी you are good here, okay. एंड आपका जो इंटर्नशिप्स वगैरह आपने नहीं बताया, एंड प्रोजेक्ट में भी आप जब मैंने आपसे पूछा था दैट यू हैव कट शॉर्ट इट, दैट आई एम नॉट एबल टू रिकॉल। इफ पॉसिबल आपका जो बेसिक्स जो है, यू आर स्ट्रांग इन योर फंडामेंटल्स एंड बेसिक्स, आपका जो प्रोजेक्ट में इसमें ऐसे चीजों में भी थोड़ा वर्कआउट करके जाइए, आपका हो जाएगा।
यस सर, प्रोजेक्ट अभी तक एक बार भी गो थ्रू नहीं किया है, वो कर लेंगे।
वंस योर फंडामेंटल्स आर स्ट्रांग, यू मे लुक इनटू दोस थिंग्स, ओके। सो दैट आपका इंटरव्यू जो है ना, एक डिस्कशन जैसे बन सकता है, चीजों के ऊपर डिस्कस करोगे, मैंने ये किया, अच्छा ये किया तो क्या क्या देखा आपने, ऐसे ऐसे इट विल बी लाइक ए डिस्कशन।
यस सर।
ओके तमन, और कुछ पूछना नहीं है मेरे से?
सर स्विच केयर एंड प्रोटेक्शन है नहीं मेरा स्ट्रांग, मैंने डाल दिया था उसमें रेज्यूमे में, तो कौन कौन से मतलब फिर से आ सकता है उसमें क्वेश्चन, थोड़ा आप गाइड कर दें तो।
क्या अभी मैंने जितना भी पूछा है ना, मोस्ट टू टू थ्री क्वेश्चंस आई हैव थ्रोन फ्रॉम द स्विच गियर एंड प्रोटेक्शन ओनली, फ्यूज, आइसोलेटर, सर्किट ब्रेकर, एंड
यस
ये
सर।
स्विच गियर कंपोनेंट्स है ना, यू जस्ट गो थ्रू द स्विच गियर कंपोनेंट्स, स्टार्टिंग फ्रॉम द लाइटनिंग अरेस्टर, सीटी, पीटी,
यस सर।
circuit
यस सर।
breaker, relay, and the types of protection techniques used for a transformer, types of protection for an individual device। अगर ट्रांसफार्मर को प्रोटेक्ट करना है तो मुझे मैं क्या क्या करूंगा, जनरेटर को प्रोटेक्ट करना है तो क्या क्या करूंगा, ट्रांसमिशन लाइन को प्रोटेक्ट करना है तो क्या क्या करूंगा, बस।
यस सर।
ये
और
ये
सर
ये
जैसे जैसे सर रिलेज से, मतलब कि रिलेज पढ़ पढ़ रही थी मैं थोड़ा देर पहले, तो उसके अगर सर्किटरी में जाए तो मतलब उतना टाइम नहीं है उसको पढ़ने का, यूज तक तो कवर कर लेंगे।
यस यस, नो नो नीड टू गो इनटू दैट सर्क्यूटरी ऑफ व्हाट काइंड ऑफ, आपने जो देख रहे हैं वो इंडक्शन कप रिले, वो वाट मीटर रिले, ऐसे सर्क्यूटरीज का बात कर रहे हैं, ऐसे रिलेस कोई पूछेगा नहीं आपसे उधर। नो वन विल
जी
आस्क यू
सर।
टू ड्रॉ। ओके।
सर ये सर डिस्टेंस डिस्टेंस रिले में फर्दर फिर टाइप्स है तो उसका भी सर्किटरी है
नो
अलग
इतना
अलग।
इतना नो नो, इसका इतना अंदर जाने की जरूरत नहीं है। आपने
ओके
आपने
सर।
वो डिस्टेंस रिले का अंदर जो मूव रिले वो सब जो है ना, दो हजार, अभी आपका फील्ड के एक्सपीरियंस के हिसाब से वो जो है यूज किया जाता है, जो आपसे है ना, डिस्टेंस रिले क्या होता है एंड हाउ इट इज गोइंग टू सेंस द डिस्टेंस। डायरेक्शन रिले क्या होता है, हाउ इट इज गोइंग टू सेंस द ओरिएंटेशन ऑफ डायरेक्शन ऑफ फॉल्ट। अभी मेरा रिले
जी
इधर है,
सर।
तो हाउ इट इज गोइंग टू
हाँ।
सेंस फॉल्ट, इधर लेफ्ट साइड आ रहा है राइट साइड आ रहा है, उसका उसको कैसे पता चल रहा है, दिस वैसे थिंग्स में आप कॉन्सेंट्रेट करिए।
ओके सर। बेसिक
ओके।
कॉन्सेप्ट जो इन्वॉल्व है उसमें।
राइट।
अच्छा।
फंडामेंटल, जस्ट मेक योर फंडामेंटल स्ट्रांग।
ओके सर।
ओके तमन्ना, थैंक यू।
थैंक यू सर।
Recording stopped.
आफ्टर तमन्ना शशांक है शेड्यूल, शशांक अवेलेबल?
Yes, sir.
या शशांक, प्लीज स्विच ऑन योर कैमरा।
Recording in progress.
शशांक गुड इवनिंग।
Good evening, sir.
Shashank, you are preparing for IOCL, right?
Yes, sir.
Shashank, can you quickly introduce yourself?
Sir, my name is Shashank Shekhar. I am from Nalanda district, which is in Bihar. I completed my schooling and graduation itself in Bihar. My graduation is from electrical engineering from Bhagalpur College of Engineering, which comes under Bihar Engineering University, which is in Patna. And recently, I am pursuing a master's from IIT Delhi in power electronics and drives. Uh, my hobbies, my hobbies is I love playing badminton, cricket, and also in leisure time, so I also love to watch South Indian movies, and yes, sir.
Yes, Shashank. May I know which year of pass out you are?
Sir, I graduated in 2023.
Currently, you are doing MTech in electronics and drives.
Yes, sir.
Shashank, may I know your internship and projects if you have done any in your
Yeah.
BTech?
Yes, sir. In BTech, I done a project on wireless power transfer system. Uh, Basically, its basic principle is Faraday's law of electromagnetic induction. Basically, it is a Tesla coil. Uh, yes, sir. And I done sir internship in PGCIL in 2022.
How many days you have spent in PGCL?
6 week.
6 weeks internship.
Yes, sir.
It's field internship or how it is?
Sir. It's on field internship.
Which station? Where it is? Which station?
Uh, so in my hometown in Bihar, Nalanda district.
Okay.
Yes.
Okay. Okay. And what have you learned in the 6 weeks in PGCL?
So I learned about transmission lines, about protection of switchyards, learn about relays, and so I also enhance my concept in power system through that that internship. And
Yes,
yes, sir.
Shashank, for your station, what is your incoming voltage?
Sorry, sir. I didn't recall.
No, even the board on the station board itself, that might be written, right? 400 kV, 765 kV. What is the station voltage?
Yes.
Highest voltage? Okay, sir. Can you draw me the SLD? Very basic SLD. I don't want any detailed SLD. Can you draw and show me the basic SLD of that station?
ऐसा कॉपी पे बना के ऐसे शो
Yes,
करें.
sir. Yes. Take 1 minute and basic banao. What you have seen over there. That is SLD. Okay. Okay, Shashank. Just show me whatever you have drawn.
One minute, sir.
Okay, Shashank. Just leave it. Just show me just whatever you have drawn. I don't want the detailed SLD. Okay. Just no problem. No problem. Just show it to me.
Didn't recall much, but
Okay. Okay. Just switch off your blur filter.
now it is visible.
No, this is not at all possible here.
Sir?
There is a generator in the PGCL station. You have drawn generator.
Yes, sir.
Generator. Have you seen the generator in the PGCL station? Power grid station. Have you seen the transformer over there?
Yes, sir.
What did you observe in the nameplate? Just to tell me the rating of the transformer.
KVA, MVA.
How much MVA it is?
500.
No, I don't know. You have done your internship.
Sir, I currently didn't remember the datas and yes, sir.
Okay. Is it power transformer or a distribution transformer?
Power transformer.
Okay. What is the difference between a power and distribution transformer? Okay, Sasank, just explain me about your project that you have made a Tesla coil, right?
Yes, sir.
Just
Sir,
explain me.
basically, sir, there is two inductive coil in that. There is a sending end and a receiving end, in which we wirelessly transfer the power. I made that for very short range, means for just phone charger and some LED glow. Its bigger stage should be EV charging in future. Should be based on that. So there is a transformer. We use rectifier, then voltage regulator, and there is two coupled coil between them. Then power transfer wirelessly, and same
What
thing.
is the frequency of what is the frequency at which you are transmitting that signal?
Fifty hertz.
50 Hz. Okay, 50 Hz you are transmitting in air.
No, sir.
No, I think after completing your project, after developing your Tesla coil, how did you test the Tesla coil is working or not?
Sir, at the output of the receiving end, I connected an adapter through it, and by moving those two coil very near to each other, the phone is getting charged or LED start glowing, and whatever distance is more, then LED glow dim or phone doesn't charge. So it is distance dependent for short range.
Okay, sir.
Yes, sir.
What are your favorite subjects?
So favorite subjects are power electronics, electrical circuits.
Power electronics. Okay.
And sir,
Well, you are already doing MTech in power electronics. So,
yes, sir.
IGBT and MOSFET, which is preferred for high frequency signals?
So preference would be sir MOSFET.
Why
for high
MOSFET is
switching.
preferred for high frequency switching? Okay, Sesang, just tell me the different types of rectifiers.
So basically, there are 4 types of rectifiers: AC to DC, AC to DC converter, and DC to AC converter, AC to AC converter, and DC to DC converter.
No, these are 4 types of converters. I am asking rectifier.
Oh.
Rectifier.
So sorry, sir. So rectifier, so single phase, 3 phase, and
Okay, in single phase, how many
yes.
types?
So based on different type of load, there are various rectifiers for
There are
our
time
load.
controlled rectifier, uncontrolled rectifier,
Controlled rectifier,
and uncontrolled rectifier.
and uncontrolled. Yes, sir.
In uncontrolled rectifier, how many
Uncontrolled
types?
diode, and controlled is thyristor.
Okay, in uncontrolled, how many rectifiers are there?
Same, sir. Single phase, 3 phase should be there in
Okay, in
uncontrolled
single phase,
also.
in single phase uncontrolled, how many types?
So based on the load, it should be classified.
Okay, my load is I need to drive a small DC motor. This is my load.
Yes, sir. Yes, sir.
Now tell me how many types can be possible.
DC motors are simply RL load. Yes, sir. Type should be, sir.
See, Sasank, have you studied about this different, directional relays?
Directional relays,
Yes.
different servo, IDMT, that one, sir.
Okay, whatever. The IDM, these are curves. These are tripping curves. IDMT, very inverse. These are curves.
Tripping curves. Yes, sir. Very
You're
inverse,
not talking about
extremely
the curve.
inverse. Yes, sir.
Okay, leave it. I was talking about the directional relay.
Directional relay, sir. I heard merge price protection system, that is directional relay. That one is differential relay, I think.
That is differential relay,
Directional
yes.
Directional
Because in
relay.
PGCL station, mostly these directional relays will be used. That is why I'm asking you.
I recall distance relay type and all that. I'm not able to recall at that time directional relays.
Okay. What is armature reaction?
Sir, the reaction produced by main field flux to the armature is armature reaction.
Okay. Is it beneficial to us, or is there any drawbacks?
Armature reactions are a drawback.
Drawback only. There are no benefits.
Benefits is also there, sir.
Okay, what are the benefits?
So shifting of so
Okay, Shashank, just tell me, while switching on this MCB in your home, na,
yes, sir.
you need to press it harder to switch it on. But the same MCB, if you want to switch off, even by touching it, you can switch off that MCB. What is the reason?
I think so. Initially,
Okay, Shashank, can you explain me how this tester, electrical line tester works? Normally in our home, we used to
test.
check the voltage.
Yes, sir.
How it is working?
Basically, sir, we put it in the holder and the LED glows. So
Okay, I was asking how it is
we
working.
I think current in the circuit in that holder initiate some filament that is in holder, I think, that glows.
Okay, Shashank, we'll conclude our interview here. We'll further discuss. Okay.
Yes, sir.
शशांक, आपका इंट्रोडक्शन जो पार्ट था ना वो ठीक था. आपने यू हैव टेकन द टाइम एंड यू हैव गिवन वेरी डिटेल्ड इंट्रो. ओके.
ओके सर.
बाकी आपका जो दो अस्त्र है, एक पीजीसीएल में आपने 6 वीक्स आपने काम किया.
यस सर.
एंड फर्दर आपने टेस्ला कॉइल जैसे मोस्ट ऑफ द इलेक्ट्रिकल पीपल नोन इट एंड इट्स वन ऑफ द ओल्डेस्ट टेक्नोलॉजी. एवरीवन वांट टू डिस्कस ऑन अबाउट इट. ओके. क्योंकि काफी पुराना टेक्नोलॉजी हो.
यस सर.
सो ये दोनों चीजों
Yes,
में
sir.
डिस्कस करने के लिए मोस्ट ऑफ द इंटरव्यूज विल बी रेडी. कैसे आपने किया, टेस्ला कॉइल कैसे बनाया, व्हाट इज द सर्क्यूट, इफ यू कैन ड्रॉ, दे विल आस्क यू, दे मे आस्क यू टू ड्रॉ द सर्क्यूट आल्सो. एंड पीजीसीएल जैसे
Okay, sir.
स्टेशन में आपने किया तो आप एनी इलेक्ट्रिकल पर्सन, उधर तो सब कुछ है, आपका ट्रांसफार्मर है, बस बार है, सर्किट ब्रेकर, रिले, एवरीथिंग. तो यू कैन कंटिन्यू, यू मे लीड दिस इंटरव्यू एज अ डिस्कशन. हमने उधर क्या देखा, अच्छा ये कैसे काम करते हैं, और क्या क्या देखा, मेंटेन कर रहा है, मेंटेनेंस देखा होगा आपने, ट्रांसफार्मर का मेंटेनेंस, अच्छा ट्रांसफार्मर के मेंटेनेंस में क्या क्या किया, सर्किट ब्रेकर के
देखा सर.
मेंटेनेंस में क्या क्या. सो यस, वो कॉन्फिडेंस लेके आओ ना साथ में. पीजीसीएल में आपने 6
Yes.
वीक्स काम, एंड आपके पास एसएलडी, एटलीस्ट स्टेशन का वोल्टेज तक नहीं बताया आपने. वो जो है ना काफी आपका जो पॉजिटिव इम्पैक्ट जो भी इंट्रोडक्शन आपका एमटेक्स इसमें से है, इफ यू आर नॉट एबल टू से द वोल्टेज लेवल इन ए पीजीसीएल स्टेशन वेयर यू स्पेंड योर 6 वीक्स,
Yes, sir.
ठीक है, ये ड्रॉबैक लग जाएगी यार।
I will, sir.
हाँ, आप है ना इसमें आपका इंटर्नशिप में वर्कआउट करिए, आपका एसएलडी पढ़िए, काफी है, और 15 मिनट
ठीक
उड़
सर।
जाएगी उधर आपका डिस्कशन जैसे ले, इफ यू, वो सब आपका बताने के तरीका में ही है।
यस सर।
एंड मुझे लगा आपने ये दोनों मेंशन ही नहीं किया इंट्रोडक्शन में।
यस सर।
आईओसीएल का फॉर्म में तो भरा होगा ना? यस यस, फॉर्म में तो भरा होगा ना ये दोनों?
हाँ भरा है सर।
फिर इसमें
यस सर,
यस
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 सर भरा है।
इसमें वर्कआउट करिए। एंड आपका जो पावर इलेक्ट्रॉनिक बेसिक्स ही पूछा था मैं, कौन सी टाइप्स ऑफ रेक्टिफायर्स होता है, ऐसे ऐसे करके, मॉसफेट ही क्यों प्रिफर करता है फ्रीक्वेंसी के लिए, ये सारी जो बेसिक्स है इसमें डोंट कॉम्प्रोमाइज ऑन द बेसिक्स एंड फंडामेंटल्स।
यस सर।
काम करिए, वर्कआउट करिए, आपका ओपन करके बेसिक्स फंडामेंटल्स पढ़िए आपका, ठीक है?
यस सर।
मोस्टली बता रहा हूँ ना, एसएलडी कोशिश करिए।
सर तो वो प्रॉपर वो शो करना होगा क्या, आइसोलेटर
नहीं,
सर्किट?
सी there might be 10 to 15 branches, incomers,
sir.
2-3 incomers and 10 to 15 outgoings. You no need to draw all those things na, you draw one incomer and one outgoing, one bus bar circuit, how this incoming and outgoing
Okay,
line
sir.
is connected, simple. That is what I am asking you to draw, the single simple one line SLD showing one incomer and one outgoing. It will not take more than 30 to 40 seconds here. 30 seconds is very very
सर उसमें तो
much.
फिर वो बेसिकली ट्रांसफार्मर ही आते हैं और वो शंट कैपेसिटर जो पावर फैक्टर इंप्रूव करता है, फिर
बहुत सारे आते हैं, इतने बहुत सारे आते हैं। स्टार्टिंग में आपका लाइटनिंग अरेस्टर, वेव ट्रैप,
लाइटनिंग
सीटी आता है, इसके
वो
बाद
तो
बस बहुत सारी लाइन
फिर
है
तो
इसका।
हाँ ये तो फिर पूरा ड्रॉ करना पड़ेगा।
हाँ,
यस
इसी,
सर।
बट दैट्स नॉट गोइंग टू टेक ए 30 सेकंड टाइम, ओके?
ओके सर।
सिंगल लाइन का ड्रॉ करे, सारी लाइन का क्यों ड्रॉ करना, सारी कॉपी पेस्ट ही तो है।
यस सर।
ओके शशांक, और कुछ पूछना नहीं है तो आई विल कंटिन्यू विद द नेक्स्ट पार्टिसिपेंट।
हाँ सर, और तो टॉपिक में तो फिर फेवरेट सब्जेक्ट बोल सकते हैं, बाकी इस पे वर्क कर लेंगे।
हाँ, आप जो भी बोल रहे हैं ना, इस पे वर्क करना पड़ेगा। एंड आपने तो उसमें लिखा है, आपने पीजीसीएल में इंटर्नशिप किया है, ये सब आपने ऑलरेडी गिवन इन रिटर्न,
यस सर। यस
सो
सर।
इसमें तो वर्क करना ही पड़ेगा आपको।
और
जितना भी
सर?
क्वेश्चन है सारी सारी बेसिक बेसिक से ही पूछा हूं मैं।
यस सर।
ओके।
और सर एचआर पार्ट के लिए क्या करना होगा सर?
एचआर पर ज्यादा कुछ गैप नहीं है आपके पास। देर विल, आपने ऑलरेडी बिहार से पढ़ाई किया एंड ऊपर से आईआईटी दिल्ली जाके पढ़ाई कर रहे हैं, ज्यादा
यस
जो
सर।
है ज्यादा डिस्कशन नहीं आएगा। मोस्टली रिलोकेट के लिए पूछेगा, क्योंकि गैप नहीं है आपका, ज्यादा क्या डिस्कस करेंगे एचआर भी, डिपेंड करता
यस
है।
सर।
एंड वो सब स्पॉन्टेनियस है, उसमें आप इतना चिंता मत करना, उसमें कोई जज करने वाला नहीं है आपको।
ओके सर।
एचआर क्वेश्चन आंसर्स में जजिंग जो है ना, काफी काफी कम है। उसमें आपका पर्सनालिटी देखने के लिए हाउ यू आर गोइंग टू रिस्पॉन्ड, ये इसके लिए पूछा जाता है। ओके
यस सर।
ओके शशांक, ऑल द बेस्ट।
ओके, थैंक यू सर।
ओके,
Recording stopped.
शशांक के बाद निशांत है शेड्यूल्ड आफ्टर शशांक। निशांत, आर यू अवेलेबल?
Good evening, sir.
या गुड इवनिंग निशांत।
Recording in progress.
Yeah, Nishant, you are preparing for IOCL, right?
Yes, sir.
Yeah, Nishant, please introduce yourself.
Good evening, sir, and thank you, sir, for providing me an opportunity to introduce myself. I'm really excited. So, sir, my name is Nishant Mishra, and I'm 26-year-old. I did my BTech from Father Agnal College, Vashi, in 2023. I live in Mumbai with my family, consisting of 5 members. So, apart from studies, my hobbies are to play football and singing. And my short-term goals are to become an employee in the IOCL, and my long-term goal is to get a leading position in IOCL.
Okay, Nishan, thank you. It's quite impressive that you want to be in IOCL. Why IOCL?
So IOCL doesn't. IOCL provides you a lots of opportunity pertaining towards the large projects that IOCL right now has. It has almost 170 plus ongoing projects. And secondly, it's going to provide me a lots of opportunities to for my growth technically, as well as IOCL also provides a person to be a very it's a institute that provides you a way to be social responsible as well, because IOCL is also contributing towards the nation's growth and nation's infrastructure through various programs and through various schemes that government provides. So IOCL will not only provide me a growth in my life, but also provide me a way that I can improve my technical ability as well as my social responsibility part as well, sir.
Which year?
2023, sir.
2023, what you are doing?
So after 2023, I started continuously preparing for CBT's exam that were conducted by different PSUs. So that was my main focus, sir.
Okay, from 2023, you're preparing for this PSU examinations.
Yes, sir. Yes, sir.
Okay, Nishant, have you done any internships or projects in your BTech career?
Yes, sir. I definitely did a project which was power factor improvement in induction heating system.
That's your project. Okay, any internships?
No, sir. I was from a Corona batch, so I didn't got an opportunity. I tried a lot, but I was not able to get.
Okay. So explain me about your project that you are seeing power factor improvement.
Yes, sir. So power factor is really an important, we can say, an important component in our electrical system, because power factor, we are able to understand that how much active power has been provided to the system. So it was as induction heating is a very safest and very clean technology, but it was also suffering a reduction in the power factor because due to the inductive load, the power factor was reduced due to its lagging power factor. So we use three methods to have a solution for this problem. First was capacitor banking, but capacitor bank was really a bulky. It was a really costly process, and when we needed the most, like capacitors stores the charge for really a long period of time, and at low voltage it was really inefficient. So second method that we used was boost converter, but with boost converter the duty cycle was really high. And what is duty cycle? Is active period upon total period. So it was really active for a longer period of time, and due to which the cost, the heating effect were also being seen. And secondly, it was really a bulky system. So so after these two method, we got a solution that we should use a pulse width modulation rectifier, where we use the high frequency switching devices, which were IGBT and MOSFET. IGBT is insulated gate bipolar transistor, and MOSFET is metal oxide semiconductor field effect transistors. So due to which, as it was in a high frequency transistor, we got a uh, better control in the system. The losses were reduced. And secondly, PW rectifier provides us a nearly sinusoidal input, a bidirectional input, and the reactive power that was consumed was really low. So the two methods that we used in our project was SPWM technique, sinusoidal pulse width modulation. Second was hysteresis band current control. So hysteresis band current control was the method that we thought was really best, because there we were getting a band like upper band and lower band. We were comparing the current with the reference current, and we were getting an error current. And if that error current goes above the upper band, it's on, and lower the lower band, it's off. Yes, sir.
What I want to talk in this, you have reduced the power factor, but you have introduced the harmonics.
Yes, sir. So we also got, sorry, I missed one point, is that we also got total harmonic distortion to 5% as well.
THD you have maintained less than 5%.
Yes, sir.
Before that, 0.
No, sir. Before that, it was like around 1%, 2%. No, sir. It was greater than that, sir.
Induction heater, why there are harmonics without any converters?
Sir, so due to sir,
Because inductor is a linear device, right?
yes, sir.
So why the harmonics are there?
So I have to see that part, sir.
Okay,
Again.
it's looking like you have reduced the power factor and increased the harmonics. And this is where did you done this? This is any MATLAB simulation or how did you done this?
Yes, sir. We use simulink to simulation purpose.
You have simulated this one.
Yes, sir. Yes, sir.
Okay, okay, and simulated, and you have improved the power factor from what level to what level?
Sir, so power factor, I correctly I can't recall, but TSD we reduced to around 1% to 2%. Like it was lower than 5%, sir.
It was lower than 5%. Okay.
Yes, sir. Yes, sir.
Okay, Nishant, can you what are your favorite subjects?
Sir, electrical machine and mostly, sir, DC machine, induction machine, transformer, and pertaining to power systems, sir, transmission, distribution, stability, and switchgear and protection, sir.
Okay, okay, that's a very long. You have given your total machines and power systems.
One
Yeah.
second, sir. 1 second. And it's lagging, sir.
Okay. Now it's clear. Nishant, can you hear us? Can any okay. Nishant, can you hear me now?
Yeah, yes, sir. Yes, sir.
Yeah, Nishant.
Yeah.
Just consider a situation. I will give you two lamps. Okay, one is 40-watt lamp and another one is 60-watt lamp. Both are 40-watt 230-volt AC and 60-watt 230-volt AC. Both are connected in series. Right, okay. And across this series combination, I started applying the voltage. 100 volt, 200 volt, 300 volt, 400 volt. Likewise, I am increasing the voltage. Which lamp will fuse first and why?
Sir, so the practically we can see that 40-watt will glow brighter, so it will consume more power. So I think that it will fuse first than 60-watt.
Why the 40-watt lamp will fuse?
So because so practically if we can see that it's very bright, like 40-watt will be more brighter than 60-watt. So as it is bright, we can understand that it's consuming more power. So if pertaining to fuse, I think 40-watt will fuse first, sir.
Okay. So normally in parallel connection, 40-watt lamp will glow brighter or 60-watt lamp will grow brighter.
60-watt, sir.
Why in parallel? Why in series connection this is reverse?
So I have to have a look at that, sir.
Okay. Have you seen any transformer?
Yes.
You have seen it. Where did you see it?
So I stay in a PSU household, sir. So and in my village also I saw a transformer, and I got to know that the transformer has collapsed. So before that day, I saw the transformer.
Okay. Have you seen the nameplate of the transformer?
No, sir. No, sir.
Okay. What do you understand by percentage impedance of a transformer?
So percentage impedance is a we can also say that it's a per unit impedance. So basically, it's actual power upon it's an actual upon base value. So it's going to be same throughout, and throughout, sir, it's going to be same.
No, I was talking about percentage impedance of a transformer.
Acha, percentage impedance.
What it signifies?
It signifies that, sir, how much voltage has been provided towards the load, sir.
How much voltage has been provided to load?
Sorry, sir, percentage impedance. Sir, I don't have idea. I have to look at that, sir.
Okay. So what are the different types of core losses that we face in a transformer?
Sir, so the different types of core loss or constant loss or iron losses are hysteresis loss and eddy current loss, sir.
What are hysteresis loss?
Sir, so hysteresis loss, uh, uh, sir, one moment, sir, one moment.
Okay, okay, Nishan.
Sir, sir, I don't have any idea of hysteresis loss, sir. But eddy current, sir, but I can say that hysteresis loss can be reduced with the help of CRGO. And with respect to eddy current loss, sir, it is mostly due to the circulating current, sir. Yes. Sir, I was not able to hear, sir.
Okay, we are talking about only hysteresis. Okay, let's move on to the next question. And what is the necessity of a starter in a DC motor?
Sir, so starter in a DC motor is to reduce the starting current, which is of a very large value.
Why the starting current is very large value?
Sir, so one moment, sir. Sir, as we know that whenever we have to start a machine, we have to give it. We have to give it. So a starting torque has been produced, and to produce a starting torque, a large amount of current is used. So that's why the starting current value is high.
I was particularly asking about DC motor.
DC motor. So I have
Okay.
to get a
Okay.
look, sir.
What are the different types of starters for induction motor?
Starter for induction motors are DOL starter, auto transformer starter, star delta starter, stator resistance starter, rotor resistance starter.
Stator resistance starter. Can you explain me that?
So stator resistance is not been used much as a starter, but I have a factual knowledge about it. I don't have a detailed knowledge, sir.
Stator resistance starter, even we haven't studied. Why you want to reduce? What you will do with the starter resistance? You want to increase the resistance, or what you want to do with the starter?
Sir, so I have to get a look on that, sir.
Okay. Can you draw and explain me how a DOL starter works?
So I have to get a look on that as well, sir.
Okay. Okay, Nishant, we'll conclude it here and we'll discuss further. निशांत आपका जो इंट्रोडक्शन है ठीक ठाक था. ओके, फ्रॉम 2023 यू आर प्रिपेयरिंग फॉर एग्जामिनेशंस एंड मे बी हम जो है ये वी आर कनेक्टेड इन जूम, मे बी आप जो है कांटेक्ट नहीं मेंटेन कर पा रहे, आप आगे देख के बात कर रहे हैं. ओके, मुझे ऐसा लगा था. एंड मोस्टली कोशिश करिए जो आपके सामने जो भी पैनल है ना उसको देखते हुए बात करें.
हाँ सर, ठीक है.
ओके, मे बी वी आर इन जूम दैट मे बी मुझे ऐसे लगा था. एंड यू आर कंटिन्यूसली, आपका जो भी एक्सप्लेनेशन था ना, आप बहुत लॉन्ग कर रहे हैं. डोंट मेक द इंटरव्यूअर टू कट शॉर्ट योर एक्सप्लेनेशन. बहुत ज्यादा लॉन्ग भी नहीं होना चाहिए, उतना शॉर्ट भी एकदम मैं आंसर ही दूंगा करके ऐसे भी नहीं होना चाहिए. आपका जो है ना बहुत लॉन्ग कर रहा है. कोशिश करिए उसको, सामने वाला बोलेगा आपको ओके लेट्स गो इनटू द नेक्स्ट क्वेश्चन करके, ऐसे उधर तक मत लेके आना आप. यू कैन कंक्लूड इट क्विकली. एंड वो इसीलिए हो रहा है आपके साथ. आपने जो छोटा मोटा चीजें जो है ना, जो अननेसेसरी थिंग्स जो उधर एक्सप्लेनेशन करने की जरूरत नहीं, वो भी आप फुल फॉर्म्स दे रहे हैं.
हाँ सर.
यू आर एक्सप्लेनिंग विद द फुल फॉर्म आल्सो. उधर तक क्यों जा रहे? ऑलरेडी आपके सामने जो बैठा, दे आर ऑलरेडी एक्सपर्ट्स, दे नो व्हाट इट इज.
हाँ सर.
ठीक है, आप ऊपर से एक्सप्लेन. इफ दे आस्क यू देन यू मे गो इनटू द फुल फॉर्म, यू मे एक्सप्लेन इन द डिटेल. ओके, बाकी जो है आपका फंडामेंटल बेसिक्स आर ओके, बट ये थोड़ा ये परसेंटेज इम्पिडेंस ऐसे क्वेश्चंस जो है ना, इस पे थोड़ा वर्कआउट करिए। वो भी आपका कोई भी इक्विपमेंट का नेम प्लेट्स वगैरह देखेगा तो समझ में आ जाएगी। इसमें ज्यादा मैं नॉर्मली पूछा था आपसे, क्योंकि वो विदाउट इंडस्ट्रियल एक्सपीरियंस मोस्टली नेम प्लेट्स के बारे में नहीं पूछा जाएगा, अगर आपने कुछ इंटर्नशिप्स नहीं किया करके बोल रहे हैं ना।
हाँ
बट कोशिश करिए कुछ भी होता है तो दैट इफ यू कैन look into it and just have a look into the transform nameplates as you are giving आपका जो फेवरेट सब्जेक्ट भी मैं पूछा था, आप तो पूरा पावर सिस्टम्स पूरा मिशंस बता दिया मुझे।
हाँ सर, पढ़ा है सर, पढ़ा है।
Okay, okay, if you are having that confidence you can give it, otherwise you can cut short to the limited subjects. Okay, the starter inside the DC motor, starting में बैक ईएमएफ का है आपका मोटर के अंदर, जो आपने वोल्टेज अप्लाई कर रहे हो उसको अपोज करने के लिए।
हाँ, लेंस लॉ सर। हाँ सर।
हाँ, इसीलिए आपका स्टार्टिंग करंट बहुत हाई फ्लो होता है ना।
अच्छा अच्छा।
बेसिक वेरी, आप ऐसे मत सोचना कि हाँ ये आंसर वेरी बेसिक हो जाएगा करके। you can take the time and you think about the current equation in a DC motor, I equal to V minus EV by RA। अच्छा, स्टार्टिंग में EV 0 है, जो
हाँ
टोटल
सर।
अप्लाइड वोल्टेज चला जाएगी। एंड ये स्टार्टर रेजिस्टेंस स्टार्टर कहाँ सुना आपने?
सर वो मैं पढ़ रहा था तो स्टेटर रेजिस्टेंस भी था उसमें, शायद गलत होगा सर।
अच्छा अच्छा, ठीक है, आप पढ़ा हो तो उसका वो कैसे काम करता है। यू कैन स्टार्ट द मोटर विद स्टार्टर रेजिस्टेंस डेफिनेटली। यू कैन ऐड
हाँ
ए, it is like a rheostatic starter voltage
हाँ
reduction, but it will create huge heating।
हाँ सर।
I don't know, it will use। ओके, देख लीजिए। बाकी तो आपका जो फंडामेंटल्स आर ओके, गुड। दिस इज योर सेकंड इंटरव्यू?
यस, थर्ड इंटरव्यू सर।
थर्ड इंटरव्यू, ओके ओके। नाउ यू आर कॉन्फिडेंट?
यस सर।
ओके ओके निशांत, और कुछ पूछना है मेरे से?
हाँ सर, वो तो आपका ही, मैंने जब आपने इंट्रो में बोला था उस दिन कि मशीन और पावर सिस्टम तो खुद ही बहुत बड़े बड़े सब्जेक्ट है, तो उनके ट्रांसफार्मर को एज अ सब्जेक्ट बताया करो। बट सर कल के इंटरव्यू में क्या हुआ सर कि सर ने जैसे मैं एक क्वेश्चन पूछ लिया था सिंक्रोनस मशीन से कि लैगिंग लीडिंग पावर फैक्टर पे भी लोड पे कौन चीज काम करता है। तो सर मुझे लगा कि शायद इस चीज को भी पढ़ना चाहिए, तो इसके लिए मैंने सर थोड़ा और पढ़ लिया और वो भी बता दिया सर।
गुड गुड, नो प्रॉब्लम, डिपेंड करता है। सी इट्स दैट इज द रीजन आपको जो भी इंटरव्यूज जो है वी आर गिविंग इट विद मिनिमम टू मेंटर्स।
हाँ सर।
ठीक है,
ठीक है सर। ओके।
ओके
थैंक
निशांत,
यू। थैंक यू।
थैंक यू, ओके।
Recording stopped.
After Nishant, Joseph is scheduled, I think.
Yes, sir.
Joseph, just give me a minute, just 1 minute. Huh? Okay, okay. Okay, okay. Amal da call பண்ணிட்டாரு, அங்க ப்ராப்ளம் எதுவும் இல்லைன்னா ஓகே ஓகே, அவர் கால் பண்ணி சொல்லுங்க. ஓகே, ஓகே. Yeah, Joseph.
Good evening, sir.
Good evening, good evening.
Should I?
Recording in progress.
Yeah, Joseph. Introduce yourself.
Sir, my name is Joseph Martin. I am from Kerala and I did my schooling in Thrissur, Kerala, and I completed my BTech from Government Engineering College, Thrissur. I passed out this year and have been preparing for PSUs this month. And my favorite subject is power electronics and yes, sir. And that's all. I did my project on microinverter for PV system.
Micro PV system. And
Yes.
any internship?
I did my internship, 5-day internship at KSCB, Madaketra 400 kV substation. Sir.
KSCB 400 kV station.
Yes, sir.
What did you see over there in this 400 kV station?
There was yards, 400 kV yards and 220 kV yards along with 110 kV yard too. So we focused first day on 400 kV yard, then 220 kV yard, and we saw controls, SCADA system was also. So we also saw that.
Okay, Joseph, what did you observe? What is the difference in your first day and second day, looking at the 400 kV switchyard and looking at the 220 kV switchyard? What is the main difference that you observe?
So the size was larger compared to 220 kV. 400, there was 2 feeders for 400 kV. So then we also had 10 units of transformer, 3 each for 3 phase. It was auto transformer, and for 220 kV, I think there was one single 3-phase unit and as well as 3 single-phase units.
Joseph, you're saying from 400 kV there are 3 auto transformers.
Yes, 9 auto transformers.
9 auto transformers. Yes. 3 for individual phases.
Yes.
Why? What is the necessity of having independent transformers rather than a single 3-phase transformer?
So first of all, transportation is a major consideration. It will be a big transformer, so transportation is difficult. And auto transformer has we can save copper in auto transformer. That's also. So its size is larger, and we can also, there is also maintenance. So we have 10 units, 1 for spare, and we can just maintain easily without uninterrupting power supply. So.
Okay, Joseph, what is the rating of your auto transformer that you have seen over there?
I think 105 MVA for 1 unit, and for 3 units it's 315 MVA.
315 MVA can be made as a single transformer.
I don't know about it.
Okay. And can you explain me about your micro inverter PV system project?
Yes, sir. We did a microinverter PV system. It was done as 2-stage. So first of all, for a normal system, we have different panels. We connect it in series to increase the voltage and parallel to increase the current. Then we connect all of it to a central inverter. So there are 2 major problems. One is the central inverter is there is only one inverter. If it fails, the whole system fails. And another problem is when there a partial shading occurs. So for example, one of the panel gets shaded, the current through the whole series of that panels get reduced and efficiency drastically reduces. And in case of micro inverter, we have small inverters for each panels. So in each working in MPPT, and in any case one of them gets shaded, the others are not affected. We get full efficiency from all panels.
Okay, Joseph, but how you are going to think all these micro inverters as a single unit?
So we do connect them to grid by grid synchronization. So we did our project in 2 stages, and we built one first stage DC-DC converter. Then we have another inverter to connect it to grid. So well, we completed the DC-DC converter part as hardware, and we simulated the inverter part. So.
Okay. So what do you understand by MPPT?
So MPPT is maximum power point tracking. So basically a panel has a particular voltage and a current at which it produces the maximum power. So in a MPPT algorithm, the controller tracks the maximum power points. So it has a slope positive on one side and negative on one side. So we can just check the slope and find the point at which it's maximum. So there are various methods for checking MPPT.
Okay, which algorithm you have used in your converter?
We used perturb and observe as well as incremental conductance methods. So we did simulation both and compared it, and then we did perturb and observe, I think.
Okay. Joseph, what are your favorite subjects?
Power electronics.
Power electronics.
Yes. And circuits too.
And electrical circuits.
Yes.
Joseph, can you explain me how a electrical line tester is working in our home?
Line tester. So,
Electrical tester that we are checking, na, power available or not available.
I don't know, sir.
Have you seen the tester?
Yes, sir. It lights
Have
up
you
when
used
we
it?
place it. Yes, used it, sir.
Okay. Can you explain me how the MCB works?
Yes, when overcurrent flows, the relay in the MCB trips. Basically, it's a magnetic coil. So when current flows increase, it applies a force on the tripping circuits.
Okay.
I think there is also thermal tripping, where there is a sustained flow of overcurrent. It trips by thermal.
Have you seen MCB in your home?
Yes, sir.
Have you studied what are all the details written on the MCB?
Yes, sir. There are MCBs for 6 ampere MCBs for normal circuits, sir, and 16 ampere MCB for power circuits, sir.
Okay, the 6 ampere MCB, what is the fault current rating?
Sir, when the current goes above 6 ampere, it trips, sir.
Okay, suppose if if the current is 9000 amperes.
Sir, the circuit breakers have inverse time characteristics, sir. So, oh, okay. Then
I was talking about MCB.
I think I don't know, sir. I'll have to check it.
Actually, just look into the MCB once again, okay, in your home.
Okay. Okay.
There is be written on it. It's rated for 10 kA, 10 kilo amperes, 5 kilo amperes, 20 kilo amperes.
I'll
One
check
you
it,
are
sir.
saying is the continuous rated current, another is the fault current rating. At
Okay.
what level of fault current it is rated for?
Okay, sir. I will check.
What is the lightning arrestor?
Sir, lightning arrestor is used to protect equipments from lightning. So basically, at normal condition, it won't conduct, and when there is a high voltage, it conducts and passes the current to the ground, sir. So it protects equipment.
Okay. So can we use the maximum? What is meant by maximum power transfer theorem and where it is used?
Sir, maximum power transfer, you mean in electrical circuits, maximum power transfer means we transfer the maximum power to load. So in case we need to have our load impedance and source impedance matched for maximum power transfer.
Okay, does it used in power system? Power system में कुछ काम का है क्या? Have you?
So we can adjust our impedances to get to transfer maximum power to load, sir.
But what is the efficiency? What is the efficiency if I am going to transfer the maximum power according to the maximum power transfer theorem? Joseph, can you hear me? I think it's a problem with your internet. Can anyone confirm? Can you hear me?
Yes, sir. You are audible.
Yes, sir, we can hear you.
Okay. I think we have lost him. Okay.
So,
Okay.
I think network.
Yeah, Joseph.
Sir, I am also left.
Okay, Joseph. Yeah.
Okay,
कोई
sir.
बात नहीं,
Sir, कल का timing?
बचा है ना, we will take an extra slots tomorrow, okay?
Okay, sir.
Yes, sir. I will conclude in 5 minutes. Yeah, Joseph. What is series and parallel resonance in electrical circuit?
Sir, in series resonance circuit, we have the impedance we have real resistance only, the impedance, imaginary part of the inductor and the imaginary part of the capacitor cancels out. So we get maximum current. Whereas in case of the parallel resonance, we have admittance matched out and current is minimum. So
Current is minimum. Yes, very good. Joseph, good here. We will conclude your interview here. And I have seen most of the positive points only towards you. As you are very recent passed out, your theoretical knowledge is very strong. Okay, use it.
Okay,
And आपका जो KSEB का जो internship है ना, आप
yes,
उसका SLT ड्रॉ कर पाओगे स्टेशन का?
I don't remember that. I will learn about
Yes.
it, sir.
आपने वो 5 days internship में भी आपने जितना भी देखा, आपने जो रेटिंग्स भी बताया ना, 105 MV ऑफ ऑटो ट्रांसफॉर्मर्स, वो भी इंडिविजुअल फेजेस का, ये सारी जो चीजें है ना, ये आपको हेल्प करेगी यार. इफ यू कैन ड्रॉ दिस SLD, दे माइट आस्क यू,
Okay, sir.
एज यू हैव प्रैक्टिकली
Okay,
सीन.
okay,
एंड
sir.
आपका जो माइक्रो पीवी इन्वर्टर है ना,
Yeah.
उसका ड्रॉबैक्स भी ज्यादा है.
Yes, the cost is cost and
Cost है उसमें अलग अलग चीजों है. ठीक है,
maintenance.
इसको आप अच्छे से एक्सप्लेन करिए. और आपका जो एक्सप्लेनेशन है वो ठीक ठाक था, कोई दिक्कत नहीं है. एंड ये जो फील्ड आपका MCB की ये सारी जो फील्ड डिवाइसेस है ना, टेस्टर कैसे काम करती है, ये तो बेसिक होता है ना इलेक्ट्रिकल इंजीनियर के लिए. ठीक है, ऐसे थोड़ा प्रैक्टिकल चीजों में, जो एप्लीकेशन ओरिएंटेड चीजों में वर्क करिए. बाकी योर थियरिटिकल नॉलेज इज गुड. एंड आपका जो भी क्वेश्चन था ना, आपने थियरिटिकल अप्रोच ही मैं देख रहा हूँ आपका जो आंसर में, दैट इज गुड. ओके ओके जोसेफ, ऑल द बेस्ट. हो जाएगी आपका.
Yes, sir.
Recording stopped.
या जय सर, अभी कंक्लूड करेंगे सर आज का. रोहन is from instrumentation. Okay, Ashutosh sir will take, but no problem, I will take it. Okay. Yeah, Rohan, good evening.
Recording in progress.
Good evening, sir. Am I audible?
Yes, Rohan, you are audible.
Okay, sir.
Rohan, please introduce yourself.
Good evening, sir. My name is Rohan Markanda, and I'm from Bikaner, Rajasthan. I completed my BTech in Electronic Instrumentation and Control Engineering in 2024 from Engineering College Bikaner, and my BTech project, my BTech final year project was semi-automatic solar panel cleaning system, where I automated the cleaning system of the solar panel. And after that, I was preparing for PSUs and GATE. And recently, I am working as an pre-doc fellow at under NPTL at IIT Roorkee in EC department, and where my work is to assist the PhD scholars and circuit designing and PCB designing. And I know a little bit of microcontrollers and interfacing of sensors with them.
Okay, Rohan, which year of pass out you are?
Sir, I completed my BTech in 2024.
2024. From 2024,
Yes,
you are doing your work in IT.
No, sir. I was preparing for GATE 25. Then from July 25, I joined IIT Roorkee as a, we can say, project assistant.
Okay. You are saying you have done your project on semi-automatic PV system cleaning, right? Can you elaborate on
No,
the
sir.
project?
Sorry, sir. Semi-automatic solar panel cleaning system.
Yes. PV means solar panel only, no? Photovoltaic system.
Oh, I'm sorry, sir. I'm not aware of that.
Okay, both are same. Just explain me what you have done in the project.
So, sir, semi-automatic, we used ESP32 microcontroller in that, which is the main brain of the system, and with that for movement of the wiper, we used DC motor, and for that for DC motor controller we used L293D DC motor controller, and at the same time uh, there is a um, supply of water also, which is in the bucket, and we are controlling the pump using the relay. And let me explain what is the working of the project. When we give signal that we want to clean our solar panel, then the ESP32 checks whether the bucket is filled with water or not. If it is not, then it gives signal back that your bucket is not filled. And if it is filled with water, then it starts the pump uh, and pump. Then the water came on the solar panel, and then the wiper starts moving downwards and upward also. So this is
Okay,
the
Rohan.
complete.
Who has coded this ESP32? You have done it?
No, sir, my junior coded that, but I designed all the system. That hardware designing is done by myself.
Your junior who coded it?
Yes, sir.
Okay.
Actually, it was a collaborating project.
Okay, understood. How you are going to sense the water level?
Sir, for like we can use the sensor, we can use the ultrasonic sensor, but what I used is a limit switch with a kind of ball. Basically,
float limit switch.
Yeah, float limit switch, sir.
Okay. Can you explain me how this level measuring is working? Level measuring system. Suppose you don't have any float switch. I need the water level. 30%, 40%. How the level measuring will be done?
Sir, there are different methods we can use. First is we can directly put the wires on the different levels, and we can
No, if that is water. I was talking about normally level measurement. You want to measure the level of a petroleum product.
Yes,
level
sir.
sensors. Have you studied about the level sensor?
Yes, sir. I have studied level sensor. The most basic level sensor is that we use in our system. That is the float based, and other are some electrical methods also. That is capacitance level sensor and inductance level sensor and potentiometric level sensor we can use.
Are you sure potentiometric level sensor? You have studied this?
I've studied this, but I'm not able to recall that at
You are
at
not
spot.
able to recall the level sensor. Okay. So, Rohan, explain me the difference between this RTD and thermocouple.
So, sir, RTD is a resistance temperature detector. Basically, it works on the principle that when the temperature increase, then the resistance of that particular element changes, and its formula is R is equals to R naught 1 plus alpha delta T, where alpha is the thermal coefficient of the temperature and delta T is the change in temperature, and R naught is the previous temperature, previous resistance at previous resistance.
Understood.
And,
I was not talking about the
yes,
form.
sir.
I was asking about, my question is the difference between RTD and thermocouple.
Okay, sir. RTD is a linear device, and it is a passive device, passive transducer. And while thermocouple is an active transducer, that means it can generate its own power, and it does not need any other supply. And so
Okay, Rohan, can you explain me what are the different types of RTDs? Any example of RTD?
Sir, as of now, I remember PT10, PT100, and PT1000 are the.
Okay, PT100. Let's take PT100. What is that meaning of 100?
Sir, the 100 in PT100 stands for the 100 ohm resistance at 0 degrees Celsius.
Okay. So Previously, you have already explained the formula, right? That RT equal to R naught into 1 plus alpha naught delta T. In this alpha naught, positive temperature coefficient, metals are of positive temperature coefficient or negative temperature coefficient?
Sir, for metals, I think it is. I'm not sure that. Can I make a guess?
No, you know it. In PT 100, you are saying at 0 degrees Celsius, 100 ohm is the resistance. At 1 degree Celsius, what is the resistance?
Hmm. I think, sir, it is a positive temperature coefficient.
How much is
That
the resistance?
like it depends on the alpha, no? That coefficient of.
Right. But PT100 is the standard resist RTD. It will rise above 100 or it will fall below 100.
Sorry, sir, I'm not sure about that.
Metals are of positive temperature coefficient and your PT100 is the best linear RTD. वो जो है ना आपका टेम्परेचर बढ़ जाए तो उसका रेसिस्टेंस बढ़ता है.
Okay, sir.
टेम्परेचर बढ़ता है तो रेसिस्टेंस बढ़ता है. So metals are of positive temperature coefficients.
Okay.
Okay. Ron, can you explain me the limitations of Ohm's law?
Sir, first limitation of Ohm's law is the circuit should contain only linear devices, and the temperature should be at constant. I think constant temperature should be taken.
Okay, Ron. So why this for this field measurements? Why we are using only 4 to 20 milliampere signal? Why 4 to 20 milliampere signal is a very famous electronic field signal?
Sir, we use 4 to 20 milliampere because that we have to map the exact parameter we are going to measure. So the 4 milliampere is the lower value that we have to consider, because just in case of any failure, we will still get the 4 milliampere. But if we use 0 to 20 milliampere, then we are not able to detect whether the system is working or not.
Okay, Rohan, as you have worked on the ESP32 and as you have already mentioned that you are working on microcontrollers, right? So I think you are very much familiar that microcontrollers will not directly read these 4 to 20 milliampere signals.
Yes, sir.
So how you are going to extrapolate this 4 to 20 milliampere into pressure or into temperature?
So there are some like I'm not sure, sir, how do we use in that industry, but from my perspective, we can use a simple resistance, and when the current will increase, then the voltage across that resistance will change, so we can measure that.
With ESP32, that is the best thing you can do. Good.
Yes, sir.
Rohan, just explain tell me what is thermal runaway in a BJT?
Sir, thermal runaway is the condition where the IB, that is the base current, increases, and with proportion to that, the collector current also increases. So this is when the BJT is stuck in a loop, then the base current will increasing again and again, and then the collector current will exceed the limit of the BJT.
Achha. Why the base current will increase and again?
Sir, I'm forgetting the concept.
Okay. Rohan, can you explain me the difference between analog and digital circuit?
Sir, analog circuits are those circuits which work on continuous time signal, while the digital circuits are work on discrete time signals. That means there is only high and low in digital signals, but in at analog signal we have in between also the values are in between high and low also.
Okay, Ron, we'll conclude here. And आपका ब्रांच ईसी से
नहीं सर, इलेक्ट्रॉनिक्स इंस्ट्रूमेंटेशन एंड कंट्रोल इंजीनियरिंग.
right, then why you are not able to explain the level sensor?
सर मैंने पढ़ा है, बट वो like this is my first time I am giving interview, so I'm
This is
feeling
your
a bit
first time.
stuck.
Okay, no problem. And ये फॉर्मूला आपने एक्सप्लेन किया, इट्स नॉट रिक्वायर्ड, क्योंकि इफ यू आर कॉन्फिडेंट दैट सही था, नो इश्यू, बट अनटिल अनलेस ये रिक्वायरमेंट नहीं है, ये ऐसे चीजें लेके मत आना.
ओके सर.
ये क्योंकि पॉजिटिव टेम्प उसी फॉर्मूला से पूछा मैं आपसे, मेटल का पॉजिटिव ये अल्फा नॉट का जो है ना, मुझे भी वो स्ट्राइक नहीं है, मतलब इवन आई एम नॉट रेडी टू क्वेश्चन दैट थिंग. ये पॉजिटिव ये अल्फा नॉट कैसे होते हैं, मेटल्स का कैसे होते हैं, नॉन मेटल्स का कैसे होते हैं करके आपने मुझे याद दिलाया था.
इसमें सर जो थर्मिस्टर्स है उसका तो मैंने पढ़ रखा है, ये PT100 वाला ये फर्स्ट टाइम मेरे साथ हुआ.
Just PT100 because this is the most famous industrial RTD, no? आप
Yes,
कहीं
sir.
पे भी जाओ PT100 will be used. And BJT का जो थर्मल रहने में ना, बेस करंट का कुछ लेना देना नहीं. Once the collector current increases, the temperature increases. Temperature increases, charge carriers increases. Charge carriers increases, again IC increases. IC and temperature. This is a loop.
Okay, sir.
Is a loop of temperature and IC, right?
And
There is-
IC.
हाँ, करंट बढ़ेगा, टेम्परेचर बढ़ेगा, ऐसे ऐसे होता है. ठीक है.
ओके सर.
बाकी आपका जो ESP32 से आपने प्रोजेक्ट किया, ठीक था, इट्स वेरी गुड. बाकी आपने इंटर्नशिप्स वगैरह नहीं किए क्या कहीं से?
सर इंटर्नशिप मैंने मतलब ऑलमोस्ट 1 साल के लिए एक स्टार्टअप था उसमें करी है, लेकिन वो मैंने मेंशन नहीं किया है.
बट फॉर्म में तो मेंशन किया होगा ना, IOCL का फॉर्म में.
नहीं सर, उसमें भी मेंशन नहीं किया. उसमें मैंने जो मैं यहाँ पे काम कर रहा हूँ वो मेंशन किया है.
ओके, देन इट इज ओके. आपने कहीं मेंशन नहीं किया. इफ यू आर नॉट कॉन्फिडेंट यू कैन लीव इट.
ओके सर.
ओके रोहन,
And,
फर्दर आप
वन मोर थिंग सर, जैसे अभी मैं यहाँ पे जो काम कर रहा हूँ उसको कितना मुझे लाइक प्रिपेयर करना है. लाइक जो मैंने फॉर्म लाइक सर को भी भेजा था मैंने, फॉर्म जो मतलब वहां पे जो भेजा है वही फॉर्म मैंने यहाँ पे भी भेजा सर को. तो उसमें सर मैंने लिख रखा है कि आई एम वर्किंग ऑन स्मार्ट हेल्थ केयर मॉनिटरिंग सिस्टम राइट नाउ. तो मतलब जैसे उसमें हम ECG सेंसर्स यूज कर रहे हैं, तो उसको मुझे कितना डेप्थ में पढ़ना है कि नहीं पढ़ना है.
यू मैं तो कहूंगा बेसिक्स ही पढ़ो. उसमें आपका जो इंजीनियरिंग कंट्रोल सिस्टम इंस्ट्रूमेंटेशन इलेक्ट्रॉनिक्स जो है ना, इसमें देयर इज अ वास्ट स्कोप. ओके, उधर वास्ट स्कोप है, उसमें देख लीजिए. बाकी जो आपका अभी जो वो भी आप जुलाई से काम कर रहे हैं, एंड नो
हाँ
वन
जी.
इज गोइंग टू आस्क यू इतना डेप्थ में जाके कोई पूछेगा नहीं. इट्स ऑलमोस्ट 3-4 months 4-5 months मोस्टली. तो आपने
हाँ जी.
ऊपर से भी मोस्टली जो मेन टॉपिक्स और उसके कैसे काम करता है वो बेसिक्स बता पाओगे ना, दैट्स मोर देन एनफ. उससे ज्यादा एक्सपेक्टेशन तो नहीं रहेगा फ्रॉम मोर देन 4-5 months में. बेटर वो टाइम को आप इधर यूज करिए आपका कोर स्किल्स में.
ओके ओके
ठीक है रोहन.
ओके. थैंक यू सर.
ओके, थैंक यू.
Recording stopped.
ओके सर, मैं डिस्कनेक्ट हो जाऊंगा. यू मे कंटिन्यू. हाँ, राइट.
मुझे ड्रग्स दो, मुझे ड्रग्स दो.